So this is going to be part 2 of the Advanced Scope and Thermals plugin, and in this one I'm basically going to be covering all the setup, how to use everything, all the settings, and all that fun stuff, so you can get a rough idea on, what stuff does, how to use it, and basically just build it easily, incorporate it into your own project. So to begin, what I'm going to be covering is basically everything that you can read here in this documentation. So let's just dive on in. So to start out, here we have the root of the content folder. So we have the assets, blueprints, and demo. The demo can be ignored. That's just all this third-person default stuff. However, the assets, this is everything you really kind of need to get started. So we have all our master materials. So this goes for the post-process stuff for the thermals, the material instances for the thermals. We have the master material for the thermal, the post-process, the actual reticles themselves, basically everything that you need. So then blueprints is, as it names, blueprints. So let's go ahead and dive in and just get a rough idea on what everything does. So if we look at our magnified scope, this is going to be our simplest example. So if we click on the scene capture 2D, we have all of our settings here. So this is basically everything that is custom to this plugin. So we will start from the top and work our way down. As you can see, this works the same way as a normal scene capture component, just with some extras. So starting with the optimization, the scope refresh rate. Now this is basically one, something you can control for performance, and two, something you can control for effect. So if you're familiar with Escape from Tarkov, the thermals in that, what they do is, for balancing reasons, they basically lower the refresh rate to where the scope or the optic is a little bit laggy. So if I go ahead and play and I switch to the thermal, you can see here, it's got a little bit of a lag to it. Like the screen itself on the actual optic does not feel like it's updating super smoothly. So then the normal scopes and stuff like that, they're buttery smooth. So for the thermals, I have those set to 15. So they're updating 15 times a second as opposed to the 60 of this specific scope. Next up is capture while stopped, clear scope with color, and clear scope with material. Now these all do basically the exact same thing, just differently. So if we look at the example pawn, here I have a little descriptor here. So for when we press F, we start and stop the capture. Now the reason why we do that is when you start capture, that's going to be when you start aiming. And then when you stop aiming, you want to call stop capture. And this will free up resources that you really don't need to use when you're not actually using the optic. So this is what that fires. So when stopped, like all the clear scope stuff, that is what happens. So starting out with clear capture while stopped. This will still continue to capture the scene, but at a reduced rate or whatever you set here. So for example, when I look around, it's smooth. If I press F to pretend we're stop aiming, as you can see, it is updating super slowly and very laggy. However, this will yield me a higher frame rate because it's not using nearly as many resources as if this was doing it at 60 times a second. So if I turn that off and clear the scope with color, now when I do it, as you can see, I go to black. So you can change this to whatever color you want. And then lastly, we have clear scope with material. So this will clear it with this glass material. So I press F, and there we go. So you can kind of see when I look up, it's very reflective and all that fun stuff. So if it was down, here to your shoulder, you might see the reflection of whatever is looking behind you and all that kind of stuff to give it that glassy feel. So that's everything with scope optimization. Magnification settings. Now this is very self-explanatory. We have different magnifications, 4 all the way up to 16 power. So as I zoom in on the mannequin, I'm at 4. I go all the way in, I'm at 16. Now I'm at, 12, 8, 6, and 4, I think it was. And that's really all that controls. Now for first focal plane. So is first focal plane. This is why you see the reticle scaling up. So as I zoom in, the reticle gets bigger. As I zoom out, it gets smaller. Now what first focal plane is, if you're not familiar, that is something you'll find in higher end optics. And really for like any sort of PRS stuff, this is a must. So let's say we're at, let me move it a little bit closer to me for the sake of easy to see. So I'm trying to get as close as I can. Right here, I'm about at 3 mils. So as you can see I zoom in, let's say this little ledge here, I'm at 3 mils. This is my holdover to hit my shot. As I zoom out, I'm still at 3 mils. As I zoom in, I'm still at roughly, oh, I just moved it again. I'm still at roughly 3 mils. So it scales perfectly. So as you zoom in, your reticle will still maintain the same hold. So you can be at any power that you want of the magnification and still have correct holdovers. Now, if I disable that and we go to second focal plane, which is what you commonly find in a lot of cheaper optics, then I go to do the same thing. I bring it a little closer. I zoom in. You can see the reticle does not zoom in. So my holds are all messed up. So I'm at 2.5 here. If I zoom in, I'm at a little over 3.5, 5, 7.5, and then whatever, this would be like 10. So as you can see, we do not gain that benefit. So that's where you can control that sort of thing. And then the decrease reticle scale amount. So this goes hand in hand with an option inside the actual material itself. So I will cover that later, but you can tweak around with this. This is basically kind of how basically your reticle scales. So like the scale that it starts at and increases to. So you can control the reticle size manually in the material itself to set a default size. Then inside the optic itself, you can actually tweak it here. So each optic is specific to it. They each have their own. Next up, we have the reticle settings. So here's the reticle material index. So this is specific to your optic, your mesh. So if I click on it here, and we have 2 elements for materials. The first one's going to be for the body. And then if I go over here to the glass, if I change that to something else, you can see it changes. So this is what we would see. So that tells us that, okay, element 1 is going to be my reticle. So I want to make sure I set the reticle material index to 1. And if I look at one of these here, the thermal sites, actually I better click on the mesh. You can see element 0. This is actually the crosshair itself. So if I change that, it basically clears it out. So we want to set element 0 for the reticle material index. So this is going to be dependent on your mesh. Then lastly, we have our reticle materials. So this allows us to switch between whatever materials we have here. So in this case, I have the default reticle and then the reticle circle. So when I press O, I am switching between both reticles. And you can add as many as you want, and you can just easily cycle between all of them. All right. Lastly, we have the turret adjustment type. So right now this is in MRAD, so milliradians. So basically, let's go ahead and look at the turret. We are at 0 mils. So here we're at 0 mils. This also just kind of show off another little feature. And here we have the right, well, we're also at 0 mils. So let's say I go ahead and I zoom in on this guy. I'll zoom in right on the top of his little ear, and I'll spam page up. So that was about 20 clicks. So what we can do is you can see the reticle move down. We're at 1.8 mils of adjustment, and we're roughly in line with here. So this controls how far you each click adjusts your reticle. So in milliradians, we're at 0.36 of an inch at 100 yards. With MOA, we're at 0.25 of an inch or a quarter inch at 100 yards. And yes, I know, and with MOA, 1 inch at 100 yards is not actually correct, but that's how everything in modern times is used. So at 100 meters, milliradians is 1 centimeter, I believe, at 100 meters. So that's what you can take into consideration. So which one you want, you can have your own unique options with it. So if we kind of go ahead and look, we know milliradians is going to be more. So let's go ahead and aim at this corner here. And I'll just go up to something high. So we're at 4 right there. Press F8. Let me see how many clicks. So we are at 5.4 mils. Okay, so let's go ahead and change this to MOA. Do the same thing. Go up just a tad. Oh, come on now. Close enough. And we're also going to go to 4. Press F8. And we went all the way up to 7.2 clicks. Or not 7.2, but you know what I mean. So you can see the adjustment is a good bit different. So between the two. So it all depends on which system you want. So now that we've covered basically everything you need to know about the scene capture component, let's check out the materials. Nothing to make you hate living in the place that you do when the people are nonstop loud and they know you're busy doing something that is volume sensitive. Okay, so to continue with the reticle, or the material, sorry, this is the one that we use for the scope. So this is going to be the first reticle, as you can see here. And what we have in the material is you set the render target that you want to use that gets applied to said material. Then you control all your iBox related stuff, then the reticle stuff. So the iBox is relatively simple to explain. So I'm actually going to drag this off as a separate window, hit play, and I'll push the scope away. So here we're just getting shadow. I'll go back one more. And let's see, how can I do this a little bit easier? Let's look at it. So the iBox diameter is 70. If I change this to 40, you can see the iBox shrinks. So overall, the size of the iBox is a lot smaller. You can see like it's not getting any bigger, like it's hit its max point, I guess you could say. So that's where you want to control it based on each optic. So like this one would be pretty good fit. So it kind of like it's right at around a pretty reasonable point in my opinion. Then you have the Oddbox Range. It's kind of the same thing, but it controls how forward and back you can be. So as I would adjust this, say I shrink it, you can see it gets, I increase it. Decrease it. It goes ahead and it actually gets smaller. I reset it, gets bigger, so on, so on. So that's what that handles. Then you have the actual sharpness. So let me bring this in just a little bit. And we're at 5. Let's bump this up to 20. 100, you can see it's a very sharp line. Set back to 5. Go to 1. You can see it's a very slow fade. So on and so on. Pretty simple. Then how much is shrink the shadow by? So that's less. That's more. You can kind of control how much it shrinks by based upon these values and how far and where your position is on the optic itself. So now we're going to want to check out the colors. So I'm going to go ahead and open up the other material for the reticle circle. And I'll show you why. Let's go ahead and load this up. So this goes based upon masks. So here's the actual reticle itself. It's just a red outline with green dots. So remember that. So I hit play. I switch over. Let's make it pretty big. So we have the green channel color. So remember the 2 dots themselves, those were green. So I can kind of tweak and I'll make it green now. Now they're green. Now they are not emissive. Now they are very emissive. Now they are super emissive. Stuff like that. So you can kind of control how you want them to be. Same thing goes for the red. Remember the red was the outer ring. Now the outside ring is purple. So you can kind of control these on the fly based upon their values. Same thing goes for emissiveness. So you have red, green, and blue. So you can basically make changes either at runtime if you want to control, kind of like give the effect of an illuminated reticle, or if you want to just kind of really kind of expand upon this whole system and just arrange it on the fly, or have different reticles that all use the same texture. Then we have the reticle size. So this is the default size. So if I change this to 0.5, I'm actually going to have to, I have to restart for that one. So we're at 0.5, hit play. As you can see, now it's basically this is the size. So we're smaller than his ear, or roughly about the same size of his ear. If I go back to 1, now you can see it is bigger than his ear. So that controls the actual default size of the reticle. So pretty straightforward. Everything's self-explanatory in what you need to do. It's just up to you to tweak it. So now we have all the information we need for everything. Let's go ahead and basically make ourselves a scope. So to do this, I'm going to actually first disable the spawning of the default scope with the example pawn. So that way we don't have anything to really interfere with it. So I'm going to make mine in content. We're going to create a new actor. I'm just going to call it tutorial scope, I guess. Add a static mesh component. Make that the root. You don't need to do that if you don't want to. And then we're going to add a 30 millimeter scope mesh to it. So here we are. Now we got to add the custom scene capture component, so the SKG scene capture. Let's rotate that to face the direction of the scope and move it just in front of the bell. And put it right in the middle. Okay, now lastly, if you recall right, we have to set the render target. So the materials that we just showed, those are using the magnified scope render target. So we're going to select that. Okay, now let's start from the top. So I don't want this to capture when I'm stopped. I want this to clear to a white color. Then I want this to be I want this to go from 1 to 8 power. So I'll do 1 power, 2 power, 4 power. Screw it, we'll go to 6. Then 6 power, I want this to be first focal plane. I want it to have only one reticle. I want that to be the circle, so 30 millimeter scope reticle circle. And then the last thing I need to do is set the component tag. And that's something I'll explain here in a second as I show you. So let me drag and drop this into the world, rotate this around, get it positioned. Somewhere in there should be pretty good. So I'm going to go ahead and press simulate. Now, as you can see, we still have the grid here for the reticle. So for this material, it has not changed. Now, the reason for that is if we look at some of the other blueprints, such as this guy here, you can see in begin play, I have set owning mesh manually if you don't want to use tags. So basically, this static mesh here, our site mesh, if we search for tag, there is no component tag. So if we click back on the scene capture component and we look at the scope component tag, it says SKG that you can change to whatever you want. All we have to do is create a tag on the scope that corresponds to the same value as the one that is right here. So if we didn't want to do that, then we would have to call set owning mesh and pass in the static mesh to it. So now when we hit simulate, as you can see, there is our mesh. So everything's good to go. We have our simulated eye box. It's a little wonky right now, but we're for the most part good to go. However, there's a problem. So when I pan around, it is not working. Now, the reason for that is due to the way that the system is set up specifically for multiplayer. So this makes it easy so you can just basically drag and drop these scopes around in the world and they'll just work. However, you only want your own owning a scope to be active. If you have, let's say, 3 different magnified optics on your rifle, you don't want all 3 of them to be active. You only want one, and that'll be the one that you're using to aim with. And you only want to control this locally. So basically, I'll do this in my FPS plugin on ownership and whether or not I am aiming. So when I start aiming, I enable it. When I stop aiming, I disable it. So in this case, we want to enable it. So I'm going to drag off this guy and search for start capture. Compile, save, hit it again, and now you can see we're actually zoomed in at a proper 1 power. And as I move it, as you can see, it just works. Now to show you that other feature, give you a rough idea on it, that'll be the, let's see, what was it under? Yep, decrease reticle scale amount. So if we're at 8, let me change this to 1 just so you can see what it does. Hit simulate. As you can see now, it is a lot bigger. So basically that's what you use to control the scale specifically for each different scope. So different scopes might have the same reticle, but you might want them to be scaled differently. So we now have one that's good to go. Now let's go ahead and create a thermal, because that's a little bit different of a process. So what I'm going to do is I'm going to actually Control W to duplicate this so we don't have to tinker with anything else. I'll call this one tutorial thermal. Let's go ahead and you really don't need to change the static mesh. I'll actually show you how to do it with this one specifically. But because we're using a different material that uses a different render target, I want to select the render target thermal for the texture target on the scene capture component. Then go to reticle settings, change the reticle material to be the thermal crosshair. So mi_thermal crosshair. Okay, now let's go ahead and replace that. So I can drag this out, delete it, then click on the one we just placed. Right click and replace with tutorial thermal, like so. And we hit play, and you can see nothing's happening. The reticle itself is different, but we don't have the thermal result. It's because we need to apply the post process to it. So the way you do that, click on the scene capture component, scroll down to post process volume, go to rendering features, post process materials, add an element. We're going to choose asset reference. And for the dropdown, if you just search for MIPP, you'll see all my materials. So we have two, one for white and one for rainbow. So we'll select the white hot and then try it. Oops, I seem like I forgot a step. Never mind, I didn't forget a step. I forgot what actually setting to tweak. So we have to do one more thing. So this capture source here. So this is where I always find it good to have a reference. So if we click on, I need to actually add this to the documentation. Here we have the example thermal. And if we scroll down on this guy, what we have is final color, LDR, and RGB. So we need to make sure that that matches. So final color, LDR, and RGB. This will allow you to actually get that thermal view to it. So you can see now the mannequin is glowing white hot. And then if I go through and if I change the post process to rainbow, we get the new rainbow effect. So let's go ahead and quickly cover those materials. So with the white hot, you basically have how far out you want this effect, how much noise and shimmer that you want to have between these. Then here you can tweak the colors based upon your liking. So for example, the rainbow, here you can see the effects of each color, like so. So the hot is going to be pink, the cold gen hot is going to be blue, and it's kind of hard to get a good lineup, but the sky, that's the dark blue, so on and so on. It's pretty straightforward. Not really a whole lot to add to it, but yeah. So that wraps up just about everything that you would need to know. The only thing that I want to cover now would be the pawn. So for the example usage. So this is very simple. Basically all I'm doing is I have my magnified scopes here for the example, and I get the scene capture from them. So all this does is it returns the SKG scene capture component. That's it. So if we look at this list of functions here, so we drag off SKG, we have zeroing. So here we have some events that we can bind. Here we have all the stuff in the scene capture component themselves. So we can get the magnification that we are currently on, get the magnification sensitivity, which I'll show you here in just a second, adjust your zero up, down, left, and right, set the owning mesh and pawn, start and stop capture, and zoom in and out. Then for the reticle, we have cycle reticle, and then you can actually set which reticle you want to be on directly. So that get magnification sensitivity. That is what I use right here for the axis turn and look up. So basically, let me go ahead and delete this guy and go back to the pawn and plug it back. Yep, I already did. Plug it back up. So when I'm here, let me go ahead and do a full 360-degree turn. So I'm starting with my mouse at my keyboard, and I'm swiping all the way around. And this is about, basically if I open my hand up all the way, I'm maybe 2 inches longer than the whole length of my hand. Now let me zoom in all the way. I have my mouse at my keyboard. I swipe all the way around. I'm going the exact same distance. So here I'm at the same distance that I was before. Let me keep rotating. And now I'm basically hanging off my desk. So I've moved roughly 18 inches of mouse travel. So that's what that takes care of. So you would use this value that you get with your turning. So basically, as you zoom in, your sensitivity gets lowered. So it's kind of scales with your magnification. So this allows you to take the longer range shots. Because if you didn't have this, and you just kind of, left it as is, then you really get a bad kind of, I don't know what you want to call it. Like it's not controllable. So here I'm at like 4 power. As you can see, it's very jittery. If I want to aim at this corner, it's difficult. We zoom all the way in. It, like, just the tiny little micro movements, like it's almost impossible to do so. So that's the reason for it. Okay, so that pretty much wraps up everything that I can think of that you would need to know. As always, if you have any questions or anything like that, feel free to join the Discord down below and I'll try to help you out with it. And as always, the link to this product will be in the description below. So I hope you enjoy.